Hey, Emily.
What?
Hello.
You guys hear me?
Yeah, can you hear
Yeah.
us?
But you're not muted. Why can't I hear you? Let's see.
Can you hear me?
Why can I not hear anyone? I've never had this start happening. Huh.
Can you hear me?
Okay. Give me a sec here. I did
Can
one
you
thing
hear
right.
us?
Recording without me recording it. I did set that setting.
Are you on like a MacBook or like a normal desktop?
Sorry, Emily. Just
I'm
like I was
thinking
trying to get my
yours.
headphones to connect, but they won't connect. But that shouldn't really have anything to do. Well, I guess that would have to do with
I have no idea.
headphones work. Sorry, guys. Give me a sec here. Ah, they're connected. Yay. Maybe that'll work.
Abby,
Ha,
where's your sister?
I don't know.
Not very loud, but hey, one of you talk again for me.
Hello?
Okay, just trying to get it louder. I didn't know if I had to do it on my headphones or.
Can you hear me?
Yes, I can. Okay.
Yes.
All right. Is Caitlin? Is she able to come? I am so sorry. I
They're
was thinking about time.
They were here earlier.
coming. I think she just got kicked off.
Okay. Here, I'll text her and let them know, Caitlin and Abby, that I'm on here.
It's kind of hard to hear you. Like it sounds like muffled.
If I'm closer, is it easier? Is that any
No.
better?
No.
I don't know why that would be, but well, let me try and turn my headphones off. Maybe it's trying to use a headphone from those. I need to cancel.
Sorry.
No, don't be sorry. I'm glad. Well, it wouldn't help if you couldn't hear me. So remove those for now.
Goes off. Built-in microphone.
What are you on a yoga ball? Abby?
Can you hear me better now?
Yes.
Is that better?
No.
You were like
I'm at my dining-
bouncing.
I'm at my dining room table. I always move. You know that.
Is that better for sound, guys?
Yeah.
Yeah.
Okay. All right. I'll have to see if there's a way to use the computer microphone and my headphones, but I won't figure that out now. But it's good to know that that doesn't work very well. And I'm going to text Caitlin and Abby and let them know we're here.
So you canceled the quarter project?
Yes. For now.
That's-
Because, sorry, I'm not very good at typing in. Same.
Can we get extra credit if we still did it?
Yes. Although I did try to send that to you early.
I
Probably
couldn't
will
ever
do.
figure out GroupMe because of my phone number switch. It wouldn't let me switch my phone number.
It wasn't on
And
GroupMe. It was on the
contacted
YouTube
help.
video. It was on the YouTube video. It wasn't on GroupMe. I was waiting because I couldn't get everybody on GroupMe, so I didn't put it on there, but I'm just teasing.
Well, I thought you sent the YouTube video through.
No, I texted everybody that. I just texted it normally because I wasn't seeing everybody on GroupMe, so I'm mostly teasing you just to say it wasn't on GroupMe. I just don't, I felt bad, but I wanted you to know I sent it like right at the beginning of spring break. I didn't wait till the end and then say it after you'd probably already done it. That would be terrible.
Right.
Really, my goal was just to alleviate some stress. Just, I don't know, it's just a weird time. And I don't know that everyone's heart is going to be in a science project when there's other stuff going on, much less just kind of getting through normal stuff. I wouldn't mind trying to do it still, but I was trying to think of a different format. I was like, maybe everybody could make a TikTok video of their science project or something. I don't know. I'm just joking. I was just trying to think of something creative. But for sure, if you've already done it, yes, you will get credit for it. I'm not going to not give you credit, of course.
Like, I don't think it's very good, but like, if I could get some extra credit that's not going to hurt me, that'll take.
So,
but if you're going to just grade it with the weight still on it, I'm like,
Well, let's just take a moment to breathe and like see where we're at, and then let me think how I want to do it. And then if you want to improve it some so that it's good, and worthy of a good grade, or however we want to do that. But for just this moment, yes, in some way, I will make sure you get credit for it. Let me think a little bit how we want to proceed with it. But I just felt like trying to do it this week seemed absurd. So for sure, it just needed to like go away for a little while. So
Abby, did you mute yourself?
I did 2 seconds ago.
Oh, okay, you're back. I just couldn't hear you. You were like moving your mouth, but I couldn't hear words. And I was like, what?
Yeah, that was intentional.
I know that the like normal like protocol. Hey, Keelan. I'm really sorry. Our house has been very crazy. It's not really an excuse. It has been crazy. I just had in my head 1:30. Like I thought I was doing good. I'm like, guys, by 1:30, I have to be teaching chemistry. So we need to like do this, this, and this. And I just messed up. Like, I don't know why I thought 1:30. I'm not a co-op. It just didn't, I don't know. I just messed up. But, and it is also crazy. Like, I feel like I cannot even have a cohesive thought. There's a few, if anyone knows our family well, you might know who the people are that are our house that are being difficult. But it's been a little bit intense today. So I am locked in Delia's room and she's going to have them watch Nanny McPhee. And hopefully that's what they'll actually do. So, we just realized Evangeline's never seen that. And we didn't really name her after the Evangeline in that, but maybe a little bit. So that's where we heard that name and liked it. So
Wait, what movie?
Nanny McPhee, the first one. Who is it?
I've
like
never.
No,
It's time for my.
no, I know, but we all have classes after. And I'm sorry, like, oh my gosh,
Abby, I love you. Anyway, I'm taking a Chick-fil-A course.
Hello, my favorite
I love
person.
you so much.
Okay, yes.
Peace.
I love you.
I love you.
Okay. You lock them again at the
Please,
top.
I
Don't
miss
we?
Abby and
Baby girl,
Ew.
No,
listen, I was already late, so
I
I
love
know.
you,
I need
Abby.
you.
I love you.
Not all the time, though.
Abby, I love you. You're the best.
Will you lock it at the top thing so that little people can't reach it? Just lock
Dude, my mom, like
Yes.
in that situation with like social distancing, be 6 feet away from me. Like my mom has been taking such advantage of it. She's like, do not come close to me.
Who is it? Oh my gosh, for real. I am so scattered right now.
Go. Just
No, you know, because you're gonna do stuff back there. It's like I have ADHD. I
see me.
cannot
Go.
think.
Go.
I do. I can tell you're there. I can hear you breathing.
Just like you sound like my mom.
Is Abby and Jonathan joining?
I'm hoping Abby is. That's why I'm kind of stalling here for just a
Is
second.
Why
Jonathan?
is Jonathan not?
I'm just hoping Abby.
Is it calling?
I'm waiting to see if
Delaney.
Abby's gonna.
Delaney, look at your phone.
I am. About to
Good.
So, yes, I'm
Is
hoping.
Jonathan coming?
Yeah.
He
Oh,
said he wasn't
no,
coming.
he's not gonna today.
Oh.
He's not really taking the class for credit right now, so he may hop in here and there. But that's what I was gonna say. Because we're such a small group, don't feel like you have to follow the same protocol and keep your stuff all muted.
Oh, yeah.
Yeah.
So you can just like
Okay.
ask questions easily, and unless it gets
I
problematic,
love you.
if it gets problematic, maybe it would be easier just to mute just from we'll just see. But I don't feel like we need to with such a small class. Okay, well, hopefully Abby's gonna hop in. What is she saying?
Dude, did she hang up on me for you?
Abby, can you call in?
Is Abby's thing not working?
Oh no, she told me that she was in the restroom.
I was. Sorry. Hang on. We're getting on.
She had a pee break. We all needed a
Trying to
pee.
shame you in the chat. I love you. I'll see you soon.
Is she gonna call in though?
Yeah.
Okay.
She'll be in a few, she said.
Okay, we'll just wait for her then. Here, tell my computer to please not. open the form, but-
So me and Emily both did the project. What does that mean?
You're just sorry, my phone just did something. My computer did something, and I'm trying to come back to you. Why can't I even see the screen? There it is. Thank goodness for that. Okay. We're just talking about that. Yes, you will get credit in some fashion or another. Did you just say Did you say Abby? You did it too?
No, Emily.
Oh, Emily. Yes, you will get credit.
Is it a lot of credit? Because
Yeah.
I
Yes.
wasted a lot of time.
Yes. Let me well, I feel like I should apologize, but in the same regard, I did try to tell you guys I did tell you like the Monday of spring break. And I know you guys were like on your trip, so you probably just didn't get it till you got back. But, actually nobody did because nobody watched the YouTube video. So there's like two parts to it. Nobody watched my video, even though I tried to like text you guys and tell you it was there. So there's that piece where I did say it on that Monday, but in the same regard, I realized that there's a lot of circumstantial things going on at that time. So I, for sure,
I
obviously.
didn't do any school over break. So like if somebody sent me something to watch, I just was like, I'm not watching this until after break.
So yes, you will get credit. I'm trying to decide if maybe we will still have that as a project and have everybody else participate. For now, I'm not making it official to say, yes, we're going to do it, because I may change the parameters just a little bit, but I won't, like if you've already done so, like you wrote a story, right, Caitlin? Like,
Yeah.
we'll leave it at that. If I said, I want everybody to make a video, maybe I'll have you make a video of you reading it or something so everyone can see, or whatever,
Okay.
but yes, I will not neglect to give you adequate credit for doing that. Is that
Okay.
a satisfactory
Yeah.
for you right now? Okay. However
Thank
that might
you.
look. I just want to give a little time to think how I should have that look. So I was trying to think if there's anything I said significant. I don't think I said anything significant before you got on.
Okay.
Probably not. Just talk about the project a little bit.
We just said that we're canceling the class forever and that you can all go now. Bye.
We're not going to do that. We're going to finish. We'll finish strong. But here's the very good news. We don't have a lot to finish. And I would just say once we're done, we're done. Like unless your parents have any, well, I don't think they will, because if we finish the material, we finish the material. Because we probably won't really be able to do labs. I thought about maybe I could do some lab demonstrations, but I don't really have any of it. I have some stuff here, so I'll kind of look and see if I could do a lab demonstration. We may include that, but that's still not going to be very, it's not going to add a lot necessarily. So we really only have modules 14, 15, and 16, I think. Like, that's it. So we really don't have a lot, so we'll take our time with it. So today, well, first, like, you guys all doing okay? I don't want to just jump into chemistry. Like, Emily, your house has been sick, and Abby, I haven't even talked to, Abby Nix. Like, how are you guys doing? Is everybody like doing okay? Like, are you okay in this moment? Like, are you all good?
I mean, I feel like I'm doing decently well. I've been trying to like get a lot of things done that I've like wanted to but didn't have time for. And then also, well, I mean, my sleep and eating schedule is so whacked up though, and it's kind of like I don't really know how to fix it, but I kind of need to like function in society. A little bit of Zooming that I need to do, I guess, but
Yeah.
I don't know.
My lungs went to crap and I had to go to the doctor and they told me I had bronchitis, but they wouldn't test me for the COVID-19 disease. So there's still that possibility. And I've kind of just been like dead for the past 2 weeks and I feel kind of better right now, but that's because I'm coming off of a round of steroids after coming off of a round of steroids the week prior. So it's kind of like doubled up steroids. It's all over the place.
That does not sound pleasant.
So I periodically die.
Okay. Abby, how are you doing?
Great for you.
Bottom of my screen. Quiet, Abby.
What?
How are you doing?
I'm good. I actually kind of like it. It's not bad. Yeah.
She goes, Topgolf closed, which is great.
What's that?
Yeah, it's a little sad. Topgolf closed, but we don't know when it'll start. When we'll open back up, which is a little scary, but I mean, it's all good. Like, I'm not going anywhere and spending any money, so it's all fine.
Just saving up so much. Spend a lot of hours. It's just like, I've got all this money saved and I can't even go shopping. So, like, what's the worst problem, actually? Like, you'll still have it. So.
Yeah, I know. Perfect. Yeah.
Okay. Well, good. We're doing pretty good here. I kind of like you, Abby. I don't totally hate it. I mean, I think anytime someone tells me I can't go somewhere, then suddenly I'd like to go. But if I'm home all the time, it's 100% mine necessarily. But I would like to.
I didn't have to change my lifestyle, like, at all.
Right.
I kind of like
did.
I kind of like that like you can just stay home and chill without missing out on anything.
Yeah, that's exactly it. There's no FOMO.
But I do think that it's gonna get old. Like I'm already starting to like really miss people and like miss just like getting out and feeling like productive. I don't know.
Sure.
Yeah.
Well, I think it's that sense of, okay, if I knew it was only gonna last like 3 weeks, that'd be super tolerable. But not knowing exactly how long it's gonna last,
Yeah.
makes that a
Oh,
little
no.
bit
They're
less.
not knowing exactly how long it is because people are still going out and like
Exactly.
things.
Well,
and
I think the other day
quarantine, like,
they said it was going to last till April 30th.
Yeah, I think that's accurate. Well, at least like from a country perspective, I'm sure most states, because Indiana's a
yes.
hot spot. So yeah, I think it is at least till the end of April. So it will be interesting.
I've heard lots of things. I've heard people say that like if people continue like doing the things that they're doing now, that it could like last for like a year.
I've heard that, but you know what, Caitlin? I think there's a lot of people making speculations that don't really have like a lot to base that on. I keep telling my kids that, like, I wouldn't hold that with a whole lot of weight because I don't think the people that
I don't know what to believe is the truth because I'm hearing a lot of like different things. So I honestly have no idea.
well, I don't think a whole lot of people do know. So I think the people that are making speculations are kind of, I don't know, acting a little irresponsibly because they get people really worried and anxious and
Yeah.
not necessarily basing it on anything they know other than their thoughts about, you know, how it might go. But unless they're epidemiologists, they probably really don't know. So
Yeah.
A lot of the people that are going out are like super young. They're like, well, it's not gonna really hit me hard, but like people who can't fight it as hard are just kind of sitting there like, well, it's gonna hit me, and I still have to get groceries. Like I don't really have a choice. Like if my family has to go out and get groceries, and when I happen to touch groceries that the virus is still living on, like I cannot fight it as well as like my dad and my sister because of my mom.
yes, I think like just the wearing gloves and doing some of that helps. That I know I've sprayed groceries down with like we've got this disinfectant it's like hypochlorous acid and it's really mild actually, but it's milder than bleach, so it's not like you're spraying bleach on everything. But I don't know, I'm probably a little bit crazy about it, but in the same regard, it would be nice if it just ended and more people stay healthy. That's more likely to happen. Berkeley was so mad. Monzo touched him and he's like, Corona. And I said, Monzo hasn't left the house for like the last whatever minute, 2 weeks at least, and you have gone to work like many times, so I don't think Monzo's the one you need to worry about. So Monzo's pretty safe actually right this minute. So
Dude, we went to Culver's at the beginning of it though. Mom and I did, like when it was still like not really a big thing. And Culver's, I'm telling you, has had a down pat for the longest time. Like their
what?
there is on it.
Yeah,
They've got like tongs to get the fries out that are like 4 foot long. It's like, yeah.
they seem to be they're like super busy. They've been like having record days at times, so I think because they're one of the few
They
places.
ran out of custard yesterday.
Yeah, it's really-
That's awesome.
she's very happy to be still working. So anyway, okay, so I think today it's supposed to be project presentations, which clearly it's not. So I would like to go through the test. It didn't go as well as I would have hoped. I can tell you your grades. I think some of you know them. I didn't send them to everybody because I didn't want like panic to ensue.
Wait, I wonder what mine was.
I want to know what mine was too. I worked really hard.
Well, okay, like I can tell you, or maybe I'll just message you here individually so you don't have to all like I don't have to say them all out. But I don't just want to curb it because I really would like you to. I mean, we did that last time and that was whatever. But I don't want to necessarily do that again. So I'd like to just go through each of the questions today, like literally one by one. It might be me. Oh, I'm so proud of myself. I actually hope it'll work again. I can actually like connect my iPad, write on it, and you can like, I can share my screen and you can see it. It's pretty cool. So, and I actually figured it out by myself.
This morning.
Anyway, so that's a pretty nifty trick that we can use. So I have to find my stylus.
I have a question.
Yeah, go ahead. Oh, there it is. Go ahead.
So when I look at my grades, I'm pretty sure the lab section brings my grades down a bunch. And so since we're not doing any more labs and I don't have an opportunity to bring it up, like
that's a valid question. Yeah. That's a valid question. And I hadn't thought about that. So that's a valid question and a valid concern. And that's fair. Like to be mid-semester, yeah, you should have an opportunity to be able to bring something up if it was lower. So let me just think how to fix that. Let me write a note to myself. Actually, I'm gonna put it on my phone on my notes because I'm better paying attention to that than
Well, but Caitlin, you and I also have the opportunity to possibly get some credit for the project that we
but it's
did.
not going to go into the labs.
right. Because things are weighted, that doesn't necessarily fix that problem per se. So we'll fix it. Which I need to think about how to do it. So I mean, it may be that we just take it out altogether because we haven't done a lot and just weight something else higher.
Okay.
But I'll figure something out. I just need some time. It's not like an easy, just a quick fix, but I'll fix it so it's fair in some way and present that to you and give you the opportunity to say whether you think that's fair or not, because you may think of things that I haven't thought of. So
Thank you.
you're welcome. Yes, these are kind of weird times. So I just
Yeah.
want to finish strong chemistry, get you all the information, and try to be as fair as we can about grading and not like crazy on it either. So, but in the same regard, like with the test, like, I don't know, like some things just really went awry, and I don't really know why. I mean, some of it was stuff I could understand, like it was harder. I would expect you to maybe miss it. And some of it was stuff like, what in the world was going on there? So I don't know. So we're just gonna go through it like question by question. I'll tell you what, Emily.
Are we allowed to see our grade and like maybe if you like
I'm gonna do this so you're not wondering. I'm just gonna get on the messaging here and no, that's not it.
just to like know like what we specifically need to be looking for?
Well, here's what I'm gonna go. We're gonna go through each question, and you've taken it, and you'll hopefully have some memory of taking it. I'm sure when you actually look at it, you're gonna or like as we go through it, you might like, oh yeah, I kind of remember doing that question.
Because like I studied for this like the most I've ever studied for a test before.
Same. And I was also really confident that like I was gonna do really great.
I was
because,
too.
like,
I don't know what
actually-
happened there.
And like I had all the formulas. I like remembered them and wrote them all in the back of the test.
Well, and that's what I mean. There was those, the word problems were not like the simplest ones for sure, but hold on, I'm just trying to get this last
It
one.
just felt like we went from like the homework and then the test was like stuff that like I didn't even like I'd never seen it before.
Well, no, but that I will disagree with you on that because I just took it straight from the book. I did not make anything up. I didn't there's one question I made up, but I don't think that was one that everybody missed. It was a simple one. But they were questions from, like, you know, they were questions that we've done. I would disagree to say if you say you never saw that and you studied that, that's not even necessary.
I actually do remember like doing some of them. Like I'd be working them out and be like, I feel like I've done this exact problem before.
Caitlin, your point is true that you just messaged to me. And if you decide, because what I'm going to do is have people retake the test. If you decide you don't want to, perfectly fine. Like,
Okay.
or you could, because I mean, your only hope is to gain some points. And so
Yeah.
I'm going to take the time to do it because I'm not going to give you a ton of homework this week because I'm going to have you work on that. So,
Okay.
and then watch some videos for the next chapter coming up. So anyway, you can decide how you want to do that. So we're going to go through them. I'm going to have you kind of tell me, what do you think was the next step? What do you think was the next step, to try to have you be thinking through it rather than just, here's how you do it. Because obviously that's not always the best thing, because you might not realize that you like would have done something else. So we can kind of piece through that. We'll see how that works. This is kind of a different like form. Although, gosh, I wish I had known about Zoom earlier. It would have solved a lot of our problems of how should we
I know.
jump on and off, and like that was a perfect solution. I've been on a Zoom call once, like years ago. A friend did it, but I didn't even realize, because it wasn't really interactive. It was just someone talking. I didn't realize how useful it is actually. But oh wow, so now we know. Now we have a good solution. Oops. Sorry, I'm trying to get my whiteboard up here. So like the first question was, the Caitlin's here. From long ago, 3 weeks ago, what two things increase solubility of a gas and liquid? Well, a lot of you put the right two variables, but you have to remember, like, you have to say whether they're increasing or decreasing. So it was pressure and temperature, but higher pressure, you have to say whether it's higher or lower. And I guess I could see that oversight, but in the same regard, like, it's also like a good lesson in like just kind of taking your time with things, reading the question carefully, and like pressure and temperature both affect solubility, but if those are things that can change, you got to make sure so I gave you half credit if you had the variables right, but if you, who's coming in? Okay, sorry. But if you didn't say which direction, you know, higher or lower, then I just gave you half credit. So
Can you like send me a picture of my test that's like marked so that I know what I got wrong?
I'm not going to do that right now because I do want you to retake it. And if I go through everything with you and I show you the test, because I wrote a lot of notes on there for you about like, hey, you need to do this, or this had to get plugged in there.
That's just like how I would study better for it this time, I guess. Like I just don't know how to study without seeing that and knowing what I got wrong, to focus on areas of where I'm less strong.
I hear what you're saying. I'm just trying to find a way where like it's still a test and it's not just homework. So I'm trying to find a way that like challenges you a little bit, but get like, if I go through every single question on the test, what I would say is I am recording this so I can post the recording. I think on YouTube I have to I don't know that. I don't think it's in Zoom. I think I have to post it somewhere. Do you need anything? I'm so super distracted trying to teach this. Everybody just keeps coming in and out. It's like, what do you need? can I just keep going without, like, I don't like having an audience behind me. Thank you. So I can record it and I can post it somewhere so you can reference it. So what I would say is, like, if we go through a problem today and you're like, those problems still elude me, I'm still not 100% sure on that change, and she's talking about things that sort of sound familiar, but I'm not sure I remember how to do those, then I would go find those problems and practice those problems.
Because I felt confident in like every area before we started, and like without knowing where I didn't know.
Here, we're going to go through every single question. We're going to go through every single question and we'll work through it.
Like, I was confident in my process. I feel very confident.
I know. But what I'm hoping is that you'll see, like, oh yeah, I don't think I did that. Or, and I can note, like, hey, some people had some problems with this, but I can't, like, just go through the entire test, hand you the entire test with all the correct answers, and then say, hey, retake the test. Well, if you didn't get 100%, I would really wonder why. And so it doesn't really give any challenge in, like, retaking it and trying to relearn stuff. So we're going to try this. And we're going to just try that and see how it goes and see how that. And I don't mind, like, just like that first one, like, I'm not saying everybody who missed that, but just noting, hey, when you take that, you do have to indicate whether it's a higher temperature or lower temperature that's increasing solubility. So go ahead, Caitlin.
As you're like the question you just did, like, as you're explaining the answers, could you like maybe mention like where a lot of people went wrong, because that would be helpful too.
Yeah, like that one, that's if you went wrong, that's why. Either you had the whole answer or you didn't.
Yeah.
But yes, I can do that. The next one, I'm not going to tell you what the answer is, but what I am going to say is, so it was the one that said, you'll understand why in a minute. If you wanted to protect water from freezing, which compound would accomplish this best? Assume that the molality of the solution is the same in each case. So this was just like a straight up, like, understanding the concept or not understanding. Caitlin, do you have a question? Or are you just?
No.
Okay, you can still put your hand there. I just don't want to ignore it if you did. So this, I would say, a lot of people miss this one. Not everybody. Definitely not everybody, but this is always funny to me because there's only 4 people really in the this is just a straight up case of understanding what what makes something lower a freezing point more. So I would just say, go look at that, and you might want to take notes on that. Like, maybe just go look at that and refresh your memory on what is going to make a freezing point depress more if you're looking at some different compounds. I will give you at least that it says there's one answer that says there's not enough information to answer the question, and that is not the answer. There is enough information. So it's a very easy thing. It's a very easy thing. So I would say that would be one that if it might not hurt to just go and refresh your memory and make sure.
Okay, but I'm confused about salt, because there are times when it's like, oh yeah, no, salt melts the ice, but then it also helps it freeze faster.
Well,
I'm confused on that.
Then I will go back and reread that whole entire section. Salt doesn't make it freeze faster. They talked about how like when you add salt, it's a bit of a myth. The salt does not make it boil faster. So I don't know if you're thinking of that, but salt does lower the freezing point. So anything that you add, and remember, a salt is, chemists call a salt anything that when you take a metal and a non-metal is a salt. So NaCl is not the only salt. You can have other things that are called a salt per se, but really anything that you add that's a salt that's going to break up into ions is going to lower that freezing point depression. So salt is one thing, but other things will too. But I don't know if that's what you're confusing it with. That so it always does lower. There's no gray area as to whether adding a salt lowers the freezing point. It does depress the freezing point, but it doesn't make water boil faster. And in the book, that's what they were talking about. That was the myth. People think, oh, add salt and your water will boil faster. So I guess I would just encourage you to reread that section if you have some confusion. So that's where I would make some notes to yourself. I need to reread about freezing point depression and boiling point elevation if that's something that you have some confusion. How about this? I'll do this. If I know you got it right, or I can kind of look here pretty quickly. If you got it right, for sure, I can tell you that. I'm not going to tell you every little thing that you missed someone, but Caitlin, you had that one right. So, okay. And I think, and Abby, you had that one right. So if you had, and Abby, you had that one right. So Emily, I think you might be the only one that missed that.
Which Abby?
Both Abby's had it right. Is that going to bother you guys though if I do that? Is it going to make anyone feel bad if like Emily, like if you're the only one that missed that? Well, now I already did it, so I apologize.
Can we just tell her that? Can we like tell her the answer though?
No, because it's
or like the rule?
too easy. It's one that it would benefit her more if she went back and read that section. It's not, it would be better to like, especially because that one is very simple. There's no math. It's not like there's an answer where they'll lay it out and say this, and that you could solve, you can answer just from that. So that's kind of like
It's probably in blue.
it might
It's
be
probably
I'm not
like
sure.
a
There's a
blue
lot of
rule.
formulas, but it's something that's very basic. So like,
Yeah.
for that particular one, I'm not going to just be like, here's the answer, because I feel like, one, then it's very easy to answer that whether you understand it or not when you go back to answer it. So, okay, let's just do it question by question. I think sometimes I can just say, hey, you got it. So hopefully when you do it again, you would get it again because you understood it. Okay, so number 3 says, a chemist collects 156 mils of nitrogen gas at 25 degrees Celsius and 7.9 times 10 to the second torr. The volume of that gas at STP would be, and you figure that out. So let me look. Caitlin, you missed a little bit on that, but it was a very small thing. And when we talk about what we're doing, I think you'll catch what your mistake was. Emily, you did miss this one, so you'll want to pay attention. Abby Nix, you also missed this one, and Abby Houston. So everybody should pay attention. How's that? You missed it for different reasons. And I would say, Caitlin, for like yours was just a really minor error, and I think you'll catch it as we go here. What am I looking for? I am looking for my notebook. So one thing with these kind of questions, one thing I tried to point out to you guys, that when you get a question like this, is to ask yourself, is this a gas that like something's changing, like its parameters are changing, the pressure's changing, or the temperature's changing? Because that's going to point you to use a certain equation versus another. So let me ask you, when something is changing, like the temperature or the pressure or the volume, what equation should you use? You can say it by name. You don't have to say it if you remember, but go ahead, Caitlin. You can just say it.
Is it the PV over T equals P2 V2 over T2?
Yeah, the PV over T, yeah.
What is that called?
That's a good question, because some people say that's the combined gas law.
Okay.
So think about it. It took two, like Charles's law and Boyle's law, and then it combined.
Oh yeah.
Combined gas law. That other one.
Was the one they gave us like the things in different measurements, and we had to like convert it to the right one. Like it gave us the pressure and like torr.
Well, sometimes you might have to change the like in this one, if you look, they do.
I don't have those conversions memorized because you said we didn't have to.
Well,
I will give you that. When I read that one, I thought about that. But for some of you, it wasn't. You just totally used the wrong equation. So whether you put in that volume and you didn't know it was almost irrelevant because you weren't even using the right equation. And yeah, so.
I had a question for this one.
Go ahead.
When I was taking it, I remember being confused about, so if we get it to what standard temperature is in torr, do you leave it in torr, or do we have to change it to ATM?
They just have to be the same. Go ahead. Sorry, Caitlin.
well, so the ATM, it's just one ATM.
Yeah.
So the torr on that side is going to be the exact same as the torr on the other side because 1 times whatever that was is the same. You know?
Actually, okay, let's back
Right.
up. So let's back up. So they just have to be in the same pressure. So you're right, it does change to 1 ATM. And so so first of all, you need to use the right equation. So before you even figure out whether you need to change pressure or not, you got to start with the right equation. A lot of people did not start with the right equation. So you really, whenever you come to a problem like this, ask yourself, and I don't know if it threw people off to say the volume of the gas at STP, but that is different than where the gas is at. So the gas is going to change some of those parameters. So you do use that combined gas law. So just really try to ask yourself, is something changing here? And then if it's not, if I'm just, and a lot of those are when you have like an equation, and if I had this, how much will I have if I react this much? Then you're using that ideal gas law. But whenever you have something that's like some level of temperature and pressure and volume, and it changes those, you're going to use, do not want to get from Zoom. Oh, hold on. Oh, thank you. Never mind. It was rude, actually. They were like, we're extending your time. I'm glad for it, but I didn't know what Keith's login was. I'm like, forget it. He was busy with work stuff, so I just logged in with mine, but that's nice. I'm glad that they extended it so we do not have to get on another meeting. So make sure you pick the right equation. Pay attention to what equation you need. And then, yes, with this one, and we can actually work it out, but you you're not, that torr is not, so torr at standard temperature and pressure is 760, right? Or 740, which is it? Come on, I have it written down in my notes. And you're right, Emily, I did recognize, yeah, 760, that I didn't give that to you, but for a lot of you, you missed it for reasons that were irrelevant to that, so it kind of didn't matter. I would be happy to rectify that, because you're right, I didn't say you had to memorize that. So Abby, to answer your question, they just need to match. So if I'm in torr and I'm gonna have pressure on the other side, it needs to either be in torr or I need to change my atmospheres to torrs. Either way, I just need to go one or the other and get them the same. And so, yeah, you would have to make a conversion there. And I think, hold on, there's only one person. Let me just look at something really quick here. And actually, like Caitlin, you're the only one that missed it because of that. You kept in ATM, so you had ATMs and torrs, and so you missed a point because of that. You could retake it and gain that point. So I could give it to you and say you got like an 85 or what, something slightly different, but I think you just fix it on the test and that will probably.
Will I get half credit for it?
I gave you more. I gave you like 2 out of 3 points. I think it was like 3
Wow, whatever. Who cares?
So, you still had the majority of the points for it. What was I going to say too? I can readjust that too. I told you I'd give that conversion, so I can write that in there and resend you the test so that you have that. I think I had like a typo somewhere that was kind of weird too, so I can fix that as well if that threw someone off. Let me, so let's work this. I'm going to do this share screen. So let me see here.
Ooh.
Yeah. Did it via AirPlay, but I have it plugged in right now.
Darth Vader.
Oh, is that still showing? Wolf put that. I don't know why.
Oh no, Joy is at my door.
Oh, that's funny because Wolf had put up Darth Vader as like my, profile picture. I'm like,
Oh,
Wolf, what are you doing? Okay, I'm gonna do this with AirPlay because.
this is cool. Oh, I can see myself. I look good today.
Yeah, you do.
Yeah.
Stop flirting in class.
I'm flirting with myself.
Okay. Ooh,
Now I can see like everyone.
I'm super far away from you. Oh.
sorry. Hold on. I'm gonna share. I did all that bragging that I had it all down. You know.
Oh.
Maybe I'll just unplug it. Let's see. Screen mirror. Oh yeah, I gotta do that. Zoom. I'm so glad you're there.
What? Did you just get to pick that my screen was full screen?
No, but maybe it's because you're when I'm screen sharing, it might do that. So that might be why.
One just was like, "Well, you're full screen now," and I was like, "What?"
I didn't change it, but I'm guessing when it must do that when you're doing screen share. I'm guessing, so it might be easier to see it that way though. So I can make this all the way big.
This is so cool.
I know, I'm pretty impressed with that. I thought it was neat. So, and I got a new stylus. I'm hoping it works better, mainly because I think someone took my old one. I couldn't find it, but okay. So we're gonna start out with that. Let's just write the formula. Oh, come on, you gotta be kidding me. Just bragged about this stylus and the PV over T. I can put those ones in there.
This is so handy.
I know, it's like the best. I love it. I was so excited about learning that.
Wait, what number is this test? Like for the label?
Number 3 on the, it's what?
Test 3.
Yeah, or I don't, is it our 3rd test? Yeah, because it was just going to be 4. So we'll just have one.
Oh, quarterly test 3, right?
Yeah, yep. Okay, and so we look at that and we say, so first of all, what would you say as you try to evaluate pressure 1, volume 1, temperature 1? Well, first, maybe I would say the volume of the gas at STP would be, so what are you trying to find in this whole entire equation? What do you think you're trying to find?
Can you read the question?
Yeah, a chemist collects 156 mils of nitrogen gas at 25 degrees Celsius and 7.9 times 10 to the second torr. The volume of the gas at STP would be, so we're finding a volume, right? We can at least narrow it down to that. Are we finding the first volume or the second volume?
No, second.
Does anybody else?
I don't really know. I'd have to like look at it and read it and like.
I know. I'm
underline-
sorry, Caitlin. I can appreciate that. I am definitely a look at things person. So, chemist collects 156 mils of nitrogen. So, what can we say about 156 mils of nitrogen? That's where it starts. He collects 156 mils of nitrogen gas. So that's going to be our first volume, right?
Yeah.
Would you agree with that? So you could just go step by step. So I'm just going to start like showing this to you like I need to show it to you, but I don't. So let me stop doing
What question is this? Is this
that.
3 or
Number 3.
3?
Yeah, so I'm plugging in 156 mils. That's my volume 1. Start putting these in. I really am trying to write neatly. Sometimes it's really hard to do that with this. Okay, so how about pressure 1? Do they give me a pressure? Yes, they tell me it's at 25 degrees Celsius and 7.9 times 10 to the second torr. So my temperature is 25. They tell me that, right? So I can just plug that in. Okay, does that make sense? That's the temp. So these are just the initial. Maybe instead of thinking 1 or 2, you could think initial and final. I wonder if that would be more helpful. In fact, let's put that in. So we'll leave like that 1 to be an I. Oops, stay on an eraser. Okay, and then let's change that to final.
Abby, you look really pretty when you're focusing.
Okay, so we have an initial volume and pressure and temperature, and then we're looking for a final. Maybe that would be more helpful. So that initial temperature is 25 degrees Celsius, and that initial pressure is that 7.9 times 10 to the second torr, basically 790 torr. Whoops, sorry, I went off the screen there. And so, I might have gone a little too high here. I'm gonna do that lower. Okay, so 790 torr. I'm just taking it out of the scientific notation. And so if I know, and I can give this to you when I give it to you, that had 760 torr is equal to 1 ATM. The reason I'm changing it is because I know the STP in ATM is easier. I know it's 273.15 Kelvin and 1 ATM. So for me, I find it easier to switch, and that's what I would expect, you know, that was a question. It's easier just to switch from torr to ATM. And so basically you're dividing 790 by 760, and that comes up here. I should bring a calculator up here with me. Here's my phone here. So 790 divided by 760, that tells me I'm at 1.04. So just a little bit higher ATM than STP, but it is different. So that's yes, that's going to be my initial. Okay. So then I go to the other side and I look at what the final pressure and volume and pressure and temperature are, because I'm trying to find what the volume would be then. So then I have to ask myself, what is standard temperature and pressure? And so I just told you, what is standard pressure? Did anybody catch that? You guys know it. What's standard temperature? What's standard pressure?
Isn't it 1 ATM?
1 ATM, yeah. And then the temperature, standard temperature is, here we're going to make a change.
5 Kelvin.
Yes, it is in Kelvin. So, sorry, I'm just looking at something real quick. So now we're either going to need to change this to Kelvin or vice versa. So kind of easier just to say the 273.15 plus 25 and put that into Celsius. Or wait, sorry. No. Sorry, I'm not making sense. Sorry. We're going to just change 25 into Kelvin because we're already, like, if this is, I know standard temperature and pressure, that's 273.15 Kelvin. So I need to change my 25 degrees can't stay in Celsius. I do need to be in the same units, just like anything else. So anyway, so we're going to change that 273.15 plus 25 gives me, what is that? I should just be able to add on my head, but my brain is not working very well today. So 298.15. So then I'm going to just take that out. So as you're doing it, it's fine that you wrote it in Celsius. Just make sure to go back and make sure all your units match. So I guess that would be a good, you know, if you're, Caitlin, I think you were asking, like, do I need to change this? Or yes, your units do need to match. So that's probably a good way to do that, is just to go back and recheck and make sure you've got your units the way they're supposed to be. And then I'm solving for that final volume. So at this point, I'm just down to algebra. So I just need to cross multiply, you know, these dudes, set them equal to volume times 298.15, and then solve for volume. Does the algebra part make sense to anyone when I'm like, okay, it's just the algebra from there? Does anyone?
Yes.
Cross multiplying. Yeah.
Yeah, and then just dividing by the 1. So
I
eventually,
see exactly where I messed up.
what's that?
I see exactly where I messed up.
Okay, that's good. Good. I'm glad to hear that. That's what I'm hoping. Okay, so let me erase that and look at number. So that's all there is to number 3 at that point. So it's really just a recognition. Is the gas changing? Is its pressure changing? So ask yourself, is there something changing here? Great, combined gas law. If not, probably not combined gas law. So just some critical thinking to get to the right place there. Okay, so number 4 says a mixture of 1.2 grams of nitrogen and 1.5 grams of oxygen has a pressure of 1.0 atm. The partial pressure of each gas in the mixture is. And let me just look here. Caitlin, you were good on this one. Emily, you were fine on this one. Abby, you used a completely different equation. So Abby Nix and Abby Houston, you were good on this one too. So let's just do a quick review of this. Abby, Abby Nix, I think once you, Abby, are you actually there? I don't see you, but I just want to make sure you're there.
Yes.
Okay, you don't have to leave the video. It's no big deal. I just wanted to just double check that you are there. It's kind of weird when it just says your name. You think they're there, but you don't 100% know. So, so for this one, it's just the, well, most everybody got, when we've got grams, we need to change to moles. Again, most everybody got this, and Abby, you weren't even doing this process. You were doing something else. And I've seen you do this process, so I know you know how to do it. So I'm not sure we have to go through it in great detail. But it's just when you change to moles. So if I have 1.2 grams, I can just demonstrate a little bit here. 1.2 grams of nitrogen. And if I change that into moles, I find that weight of that nitrogen, which is 28 grams, just straight from the periodic table. I find out the moles of nitrogen, which ends up being like they're really close, 0.0429. And I do the same thing for the oxygen. Oops, it's not 1.2, 1.5 grams. I'm going through it quick again, just because everyone got it. And because I know I've seen Abby do this and know she probably knows how to do it. So once I have all the moles of everything, then I can add up what the total amount of moles are. And then just take the fractional amount of each of those. So when you add them all up, it ends up being 0.0898. That's my question. I'm just adding both of those, and then I can take the fraction of each one, 0.0429 over 0.0898 and 0.04. So Abby, just, maybe review that. I think you just got mixed up in interpreting what was going on there. So maybe just take a look at those and read that and make sure that makes sense to you.
Okay.
Okay, number 5, I would have thought would have been like a gimme one, but not everybody got it right. Caitlin got it. Emily missed it. Abby got it. Abby Houston did. So so this is the one that says, does a pile of wood have potential energy, kinetic energy, neither, or both? I feel like this is one that shouldn't be hard, but I expect you to get it all the way right. So some people may have said both, but it is not both. So if a pile of wood is just sitting there, it's all potential energy. Unless something actually is burning, we're not seeing any kinetic energy. Or Delia made the point, I guess if you had if you have wood stacked up, that's more of a physics problem. It's still potential energy than if the wood was rolling down, like if it fell and it was rolling down. So it wouldn't necessarily be burning. You could have movement of that wood as it fell down, and that would be some kinetic energy. Again, more of a physics problem, but it didn't say that either, so it doesn't really mess up your answer because it didn't say wood rolling down a pile, and that would have been a trick question, I think, if you hadn't taken physics. So thinking about it, they do talk about movement, but I think that would have been a little tricky for this class. So so it's just potential energy because the wood's not getting burned. It's just all that energy is like encased there in that wood. So potential energy and kinetic energy can be a little bit hard to sort out in your head. So again, if you're struggling with that a little bit, that's a good place to take a note that I should go back and read about potential energy and kinetic energy and make sure that makes sense to me. Okay, so number 6 says, if you want to lower the freezing point 11 degrees Celsius by adding sodium carbonate, what must be the molality of the salt solution? And then I gave you that freezing point depression. Why can't I think of that as well? Like I have Alzheimer's today. Oh my word, sorry. I am a little exhausted. Wolf has had a rough night and a rough morning, and then Monzo too, so sorry. Sometimes on days like that, I feel like my brain literally short circuits at times. So anyway, that constant, there's what I want. I gave you that constant, so you didn't have to come up with that. But you did need to remember the freezing point depression formula. And let me just, again, give you, Caitlin, you had the correct equation, but what did you mistake? Something. I'm trying to see what happened here. You did have the right. Oh, I know. You missed a small thing here. And as I go through it, I think you might catch it because it's something people have been missing frequently, but we just need to clarify it. Emily, I think you might have all missed the same thing on this one. Let me see here. Yes. Abby, you missed this one, and Abby Houston. Where am I at here? Yeah, okay, everybody pay attention. Everybody missed a little something on this. So it was a little bit different for different people, but mostly everybody struggled with one thing in particular. So if we remember freezing point depression, we're gonna have this change in temperature, the amount that it changes, the amount that it,
What problem is this?
number, sorry, just move the text to number 6, thanks. Look at my notes here too, make sure I don't mess anything up. Okay, times the number of ions, times that freezing point depression constant, times molality, right? Okay, so then we got to look at all that. So change in temperature, they told us, right? They said if you want to lower it 11 degrees. So if I'm lowering something, what do you think that change in temperature? It was 11 degrees. What do you think I'm going to put in for change in temperature?
Final temperature is the initial -11.
-11, yeah, because it's going down. So -11, and then the number of ions. So let me write down the formula down here. It's Na2CO3. In Na2CO3, how many ions do you see there?
5.
And defend your answer.
There's 2 Na and 3 CO3, and together they make 5.
Okay.
No, it's gonna go into 6.
Who talked after someone said it was 5?
Me.
Can't tell who that is.
Am I wrong?
Okay, does anybody agree with that or disagree with that, or?
I would say 5, but I kind of feel like that's wrong.
Is CO3 carbonate, or is that gonna be? Yeah, so it's only gonna go into 3 then if it's carbonate.
No, look, let me
No.
show you something. Okay, this isn't going to be a right formula, but if I had 3 CO3, it would have to look like this. That's that principle.
Oh, so it's only 4.
So
or
it's
3.
actually 1. Yeah, there's 1 and 2. Just
Oh,
3.
I got that wrong.
Okay, so just watch how you're counting your ions there. So that would be a 3. And again, there's a negative sign, right? Because we're doing a, remember it's negative when it's a freezing point depression. So I still put that negative in there. And then times the constant, which was 1.86. And then the molality, which is, where are we at with molality here? Or that's what we're solving for. Sorry, we need an unknown we're solving for molality. So now we're just gonna multiply everything on the one side, and that's gonna give us, sorry. Okay, don't even look at that at all. That's completely wrong. We're dividing everything by -3 times 1 My word, I can't get my things right here. It's gonna tell me molality. Now, some of you missed that and you had the wrong molality. So the next question relies on knowing what the molality is. If you went to the next question with the wrong molality, but you did the right process, it did not take off for that. I gave you all the points for it. So that affected some of you, not all of you. Some of you didn't solve for the molality properly. So if I go to that next one and it says how many grams of sodium carbonate would you have to add to 500 grams of water to make a solution with the molality you found above? So the thing here is, you know an equation for molality. Molality, it's going to be moles of solute over kilograms of solvent. Okay, and so molality. Sometimes we're often solving for the molality, but from the last one we got a molality, which was no, that actually wasn't it. It was 2. That's not the correct number of significant figures. I'm just going to put that in there, but 2 was the molality. And so they're asking me how many grams. Well, if I need to know grams, I'm probably going to find moles first. So that is true. I'm going to find moles. I'm going to solve for moles of sodium carbonate over here. And they tell me the solvent. They say the solvent is going to be 500 grams. But here's another change. I have 500 grams, but I need it to be in kilograms. So you got to pay attention. Molality is, like the formula is kilograms. So I need to make sure that I'm dealing with kilograms. So 1,000, and some of you went backwards with this. So watch your unit conversions. Ask yourself, does this make sense? A kilo weighs more than a little tiny gram. This is like only a housefly. So, but 1,000 grams, that's not going to equal 1 gram. So always just kind of ask yourself, did I get those in the right order? Because sometimes you're just in a hurry and you get mixed up. So 5 over 10, so it's 0.5 kilos. And then I'm just solving for number of moles. And then it comes out to just about 1 mole there, that 2 over 0.5, so 1 mole. And then I'm just gonna do what we've been doing all along and change that into grams. So you're just gonna find the weight from the periodic table, put that down there, and then you'll have your moles up top. Does that make sense, that last part? Does that last part make sense? Are you guys following that? Did you guys follow what to do up here with like this equation, like how I got that and how I plug things in? Caitlin, is your screen frozen?
Mine?
Yeah. Well, you wouldn't know if it was frozen. I think it's just frozen on my end, but I don't fully realize it because I'm only looking up periodically and you have just this smiling face like.
No, because she didn't get ready this morning.
That's like a profile picture, I think.
Picture.
Say that again?
I think it's a profile picture.
Oh, okay. Are you there, Caitlin?
I am. I'm here. I am
Okay. That's
active.
okay. You don't have to fix it. It was just funny when I finally realized, no, I don't think she's frozen. It is frozen. You're not just getting in rapt attention to what I'm saying. Okay, does that one make sense to everyone? Do you have questions? Please ask them if you have it. Guys, you got to tell me what you don't understand. Like, it doesn't hurt my feelings. I feel more awful when I see you guys take a test and I think, I don't know what went wrong, because clearly it's a reflection of what I'm teaching you too. So I need to know where you don't understand. If it's something like, even if I'm like, oh, blah, 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 you just do this. If it didn't make sense to you, you've got to tell me, okay?
Did we do the molality formula different in this one than we normally did?
No, are you thinking of molarity? Are you confusing it with molarity?
No, like why is it 2 equals?
Oh, because I knew, so this one, that's a good question. This question was based on the other question. So they're saying that same sodium carbonate, if you want to make a solution with the molality of what you found. So basically, let's say you want to, you want to lower the freezing point by 11 degrees, and you found out, well, to do that, your solution has to have this molality. And so then the next question was, okay, well, if I'm mixing up a solution with 500 grams of water and I want to make sure I have that molality, how many grams of that sodium carbonate am I going to have to put in there? So I set molality equal to 2 because that was from the previous problem. So again, some of you had the wrong molality, and if you dragged over that wrong molality and you had the right equation, I did not take off for that because, I mean, I'm not gonna like penalize you just because from the outset you had the wrong number in for molality, but you knew what you were doing to get moles of sodium carbonate, you know, then that was fine.
Okay.
So, does that make sense, Abby?
A little bit, yeah.
Okay, so the molality was known. It was just known from the other problem. So
Yeah.
So 7 relates to 6, and that molality is coming. So I just set up my whole equation for molality, and then just in this case, I knew molality. Often I'm solving for it. I think that's what seems different, is trying to find what molality is. But in this case, they were saying, if you know the molality, how many grams will you need to get to that with this known amount of water? So, okay, so then number 8 says, a 25-gram piece of copper, and then gives a specific, and let me note to you right now as I'm thinking about that specific heat, it's actually not right. Actually, that was the book's mistake. I just didn't think about it when I typed it in. Just so you know, it's actually 0.385. Like if you see that somewhere else, copper specific heat, it's not 0.0385. Of course, it didn't take off for that if you solved with that. But that could throw off you might think that answer does not seem to make sense. I kind of felt that way when I was solving it, and I went back and double checked that and realized that the book just had a typo there. So that was incorrect. But regardless, you would still solve the problem the same. It might just look like a strange answer if you were thinking about it. So it says a 25-gram piece of copper, specific heat being 0.0385, joules times grams over degrees Celsius at room temperature, which they tell you is 25 degrees Celsius, loses 856.7 joules of heat. What is its new temperature? So with a question like that, kind of start thinking about like that Q and mass and specific heat and change temperature. And then we just have to start thinking about where I'm plugging things in. So they didn't give me the change in temperature. They asked what its new temperature was. And so that means there was an initial temperature and a final temperature, which is indicated by change in temperature. Now, when you plug everything in, you could plug in final temperature and initial temperature as unknowns. I like to just plug in change in temperature and then set that equal. I think the math just ends up being less messy personally, but you certainly don't have to do it that way. I like doing it that way. So I start out with this equation. So hopefully that, Caitlin, I can tell you, you did get this one all the way right. And I think everybody else had some small degree of error, but not, let's see. Yeah, you guys didn't do that bad with this one. So you know what, you didn't, guys, nobody did badly with this one. If I took points off, it was for significant figures, but it was worth 5. So here's what, I'm not even gonna work that one because you all did really great with that one. So awesome. Victory, we can count a victory for that one. So that's good, because if you understand that, when you do the more complicated ones where it's the change in energy of the metal versus the change in temperature of the water, then you're kind of doing the same thing, but you just have to interpret, grab the information out of the problem. It can be a little trickier. But just watch your significant figures. Just make sure you're paying attention to it. I hate taking points off for it, but because we talk about it so much and we say it's significant, I don't really take points off for it on your homework, but with the expectation that you are practicing it. And I do note if it's wrong so that you get some feedback if it's wrong. But it is, and Mrs. Estes and I have had this conversation, and so she holds, if you guys aren't taking physics with her, she's going to hold you to the same accountability with it. So it's not just me being annoying about it, but being annoying about it so that when you then go to do it in physics, it won't be quite as annoying because you already expect it, and hopefully be better at it by then too. So if it was a 5-point question, I did take a point off if your significant figures were wrong. So just pay attention to that. But otherwise, you guys did well on that one. So we'll skip over that and go to number 9, which is going to be similar, but a few more pieces to it. Caitlin, you were the only one that got this the closest to being correct with just a small amount of error, so still pay attention. And I actually gave you an extra credit point for that because I did think it was kind of not an impossible question. I do think if you understood the concepts, you most certainly could get it right. You did, for the most part. But I'm
just wondering, like, who am I?
Maybe you're supposed to be a chemist. You never know. Chemistry. Let me make sure my iPad's not dying here. Just a sec. Nope, I still got 49%. Okay, so so I did give you an extra credit point on that. I felt like it was well earned. You did a really good job on that problem. So so let's work through it. So let me read it to you so everybody knows where we're at. A calorimeter is filled with 150 grams of water at 22.1 degrees Celsius. A 50-gram sample of metal at 100, and you might even like write notes to yourself as you're going through, so that's helpful to you. A 50-gram sample of metal at 100 degrees Celsius is dropped in this calorimeter and causes the temperature to increase a total of 3.4 degrees Celsius. What is the specific heat of the metal? And it says you can ignore the heat absorbed by the calorimeter. Sorry, I'm like, I do this. I start thinking about something else while I'm talking, and then it suddenly looks like I spaced out, but I actually didn't. I was just like having 2 brain processes going on at the same time. Okay, let's work this question, and then I'll say what I was thinking. Okay, so we're going to use this whole Q of the metal. Why isn't that writing? Equals Q of the water plus, let's just say H2O. So I don't have to write it.
I thought it was the negative Q of the metal.
It is. Thank you, Emily. You're right. Thank you. I was just testing you. I was just joking. I did. Okay, so, and then it says we can ignore the calorimeter, so it's gone. So now we're just saying negative Q of the metal is equal to the Q of the water. That looks kind of weird how I wrote that. Let me that equal sign in a better spot.
Yeah, how did the equal sign get so high up?
Just where I started writing, it just came out goofy. Okay, so we start with that. So now we have to start asking ourselves, what can we figure out here? So what piece of hair stuck on my, Julie has a lot of shedding of hair. There's always a lot of hair in her room. Go away. Okay, so I'm going to keep my negative sign out here, and I'm just going to put a parentheses just so that negative sign is applying to everything. And I'm just going to start plugging in what I need to know, so I know what I need to fill in.
So it's going to be the mass of the metal times the specific heat times change in temperature of the metal. It's an M. It's going to be equal to mass of the water times specific heat of the water times change in temperature of the water. Okay, so I start asking myself, what do I know? Well, they tell me the calorimeter is filled with 150 grams of water. So I've got weight of the water, so I can plug that in, 150 grams. And then I can actually just move over and say, do I know the specific heat of water? You should. That was one I did tell you that you need to memorize. So that's just a memory thing, 4.184. So you do have to pay attention though with that. If you are, if your temperature is in Celsius, that 4.184 would apply to Celsius, but there's a different one for if you're in joules. So that's what we're looking for. So if you don't remember that particular unit of measurement, just go back. So if specific heat of water, something you don't, all right, it's kind of there, but not really. Just go back and review that. And then the change in temperature of the water. So then we ask ourselves, do we know that? Well, they told us that the metal was dropped in and it caused the temperature to increase a total of 3.4 degrees Celsius. So if you hear those words, it increased 3.4 degrees Celsius, what do you think that tells you about? Does it tell you about initial temperature, final temperature, or does it tell you the change in temperature?
Change in temperature?
Mm-hmm. Yeah, when it tells me what the actual increase was, I don't know the initial or the final, but I know that it's, well, actually I do know the initial because they told me, but I know that it changed. What I could calculate the final then, but 3.4 is the actual change, and that's what should go in there. So that's that 3.4 degrees Celsius. Now I'm going to go on the metal side and start to say, what do I know? I know the mass of the metal because they told me it was 50 grams. I don't know the specific heat because that's what they're asking me. So I can just quickly look and see. They said, what is the specific heat of the metal? So that's my unknown that I'm eventually trying to get to here. And then the change in temperature of the metal. So this could be maybe the trickier part of this question. Look at my notes to make sure I don't make errors and confuse you as I'm going. Oh, actually, hold on a second. Never mind. Okay, so there's two ways you can keep it going. You could actually plug in your change in temperature and you could solve completely for C. Actually, let's keep going that way. Never mind. I'm just going to be quiet. Okay, so change in temperature of the metal. So let's think through this. First, we're going to look at well, here, let's just do this. Let's just put, no, we can't do that. Never mind. We already have an unknown. Never mind that. So change in temperature of that metal is going to equal the final temperature minus the initial temperature. And so they tell me a 50-gram sample of metal at 100 degrees Celsius. So what is 100 degrees Celsius? Is that initial or final temperature? The metal at 100 degrees Celsius. It's hot. It goes in the water before it goes in the water, it's 100 degrees Celsius.
Initial.
Yes. Emily, do you have a question? Or are you signing an I? Okay. Yes, it's the initial. So it's 100 degrees Celsius initially. And its final temperature, this is maybe the trickiest part of this question, I would say. It tells me that, and this relates to the last question on the test, the water, I have to find what the final temperature of that metal is a little inadvertently, but what do I know once the metal goes in and it loses all its heat to the water? What will the metal be equal to in temperature?
The water.
It will be equal to the water. Yeah, exactly. So if I know that, I have to find out what the final temperature of the water was. Well, they told me that the water was 20.1 degrees Celsius and it increased by 3.4 degrees Celsius. So what do I need to do to find out the final temperature of the water? It's at 22.1 and it changes by 3.4.
25.5.
Yeah, exactly. Yep. So that's that final temperature. And then that's going to tell me what the change in temperature overall is for the metal, which is going to come out to negative 74.5. So now I can plug that in. Up here. So now I have all things plugged in and I just have one unknown to solve for there. And that's all there is to that one, actually. So people did a lot of varying things. What I would say is just simplify it. They just take things down to their simplest form. Don't overthink it. Think about what you know. Most of you, I think, are pretty comfortable with that equation. So write it down, and then write down what all the things are that represent that equation, and then just start plugging in what you know, and think about, you know, what you need to know to find that. So, and you know, I don't think anybody missed it just because of not knowing that. I'm pretty sure, almost certain that that was not just the main issue. So, you know, go back and review that. Make sure you know what the specific heat of water is. But if you, I would say it wouldn't hurt you to practice some of those. What I was going to say, the thought that I was having as I was reading that problem, I don't know why, it was like just popping into my head while I'm reading that problem, but I think what I'm actually going to do, and here's, okay, well, and Caitlin, I have a caveat on this for you. What I'm going to do, so I will give you, I'll send you a screenshot. I'll take a picture of your test and send it to you just by email. That'll be easier than trying to do something on here. I'll send that to you today, and you can look at what you missed and you can go through it all. I would practice one of these. Practice things are difficult. And I'm just going to actually give you a different test with very similar questions, but it feels kind of silly to like go through every single thing and then say we take it. So I'm not going to, I'll try to make it very similar, which you might be annoyed with me, but that does actually make extra work for me because I need to get an extra test together. But I think that makes the most sense because, Emily, I hear what you're saying. It would really be nice to look at what you did and see your own mistakes and your own problem, how you work through something. That's a fair request. But in the same regard, if I do that and then give you the same test, that also seems like kind of silly too. So, so I think that's how I'll do it. And then you don't have to take that. I mean, you can wait, ask me questions this week, practice some problems, clarify what you know, wait, I know she said that, but wait, now that I'm doing it on my own again, I don't really see how I'm messing up. I mean, you can even go through and try, here's a great way to study. I'll give you that test, you know, cover up your answers, whatever, try to work all those problems and see if you can actually do them and get it and make sure, you know, like hopefully you would be getting pretty close to 100%. And that would be a good indication that you've corrected some of those problems that, you know, or not corrected some of those errors in understanding as you go to retake the second one. So that would be a good way to study. So I think that that's what we'll do. So I probably won't have the test up for a couple days, but that's okay because I would expect you to do some studying before you took it anyway. Caitlin, what I will tell you is, of course, I'm not going to give you, if you retake it and you have a lower grade, which I think is highly unlikely, but if you did, I'm not going to give you lower than what you already have. So that would be true for any of you, but I certainly hope it's not any lower. It shouldn't be. It should be higher. So, okay, so that was number 9. Number 10, are you guys okay in time? I thought about that. Do you need to be at another class? What is your?
Yeah, we have a Spanish class at 30.
At 2:30. Okay, good. At least we didn't like go past it. So why don't we do this? I'm sure it's hard, like all these Zoom things. I know at our house it's like super complicated. I'm not sure how we're going to manage it. Probably we're just going to back off from some things. So I will just, while I'm sitting here right now, nobody's wondering where I'm at. I think they're still watching a movie. I'll make a quick YouTube video of just, I think there's only 1 or 2 more that are actually an actual problem to work. So I'll do that and I can talk about the last few questions and then I'll put that up on YouTube so you guys can just watch that. I'll take screenshots of your tests and get that to you by this evening. I would say like by tonight, don't be looking for it today, but by tomorrow morning, you should be able to see that in your email box. And main homework this week is going to be retaking the test that I send you. And I'll get videos up for the chapter that's coming up and then, and be reading that chapter. And that'll be your primary homework for this week, which hopefully shouldn't be too heavy overall. Does that sound all right to you guys?
Yeah.
Good plan. Okay. All right. Have fun at Spanish.
Thank you.
Later.
Thank you.
You're welcome. Bye-bye.
Bye.